to study throughput TL signal Aloha. Pure Aloha. Pure Aloha is an unslotted, fully decentralized protocol. It is extremely simple and trivial to implement. The ground rule is when you want to talk, just talk. So, a node which wants to transmit will go ahead and send the packet on its broadcast channel with no consideration whatsoever as to anybody else is transmitting or not. One serious drawback here is that you don't know whether what you are sending has been received properly or not. Slotted Aloha. This is quite similar to pure Aloha, differing only in the way transmissions take place. Instead of transmitting right at demand time, the sender waits for some time. This delay is specified as follows. The timeline is divided into equal slots and then is required that transmission should take place only at slot boundaries. To be more precise, the slotted Aloha makes the following assumptions. All frame consist of exactly L bits. Time is divided into slot of size L by R seconds. Collisions may only take place with nodes that are ready to speak at the same time, but nevertheless, this is a substantial reduction. Real life applications. First, simple radio relays were placed in operation to connect the main network on the island of Oahu to the other islands in Hawaii. Second, the applications of Aloha algorithm to anti-collisions of RFID tags.
Now we studied what throughput TL signal Aloha means. So let's do an experiment on it. This objective of this experiment is to understand the concept of Aloha principle, and the expected outcome for this experiment is to make the communication system more reliable and economical, and the same can be done by extending the concept of vibrant domains of communication. Now let's see. Uh, we fix the value of g. So what we have to do is, for every value of g, we'll have to go to console. We have to run it. So you'll get values of Aloha function. So when you put g as 0, we got Aloha function as 0. When we put 0.1, we got at 82. When we put 0.3, 165. When we put 0.6, 173, like so on. We went up till 2. So when you run this, when you run this code, you will get, for a specific value of g, you will get a specific value of Aloha. So what we did was, I previously ran this and then I gathered the value of Aloha for different values of g. Now let's plot this graph. Now we can observe when my Aloha function is maximum, when the value of g is near 1. So now this system, this Aloha principle, is actually very important, has a very important real life application. Like, radio relays were placed in Hawaii island for communication, and this helped a lot. This is it for Aloha function.